Hello everyone, and welcome back to Chess Programming Game Design with me. So it has been a while, I know that, I do apologize. I was really busy at school. A new year has started and more advanced stuff is what we're learning. I am quite enjoying school right now, but there is a lot of work to do either way. So today we are actually going to finish off our game completely. As in the logic part anyway. In the next few lessons we might make a few touch-ups, such as dealing with the graphical interface, so once somebody wins we actually tell them that they've won and things like that. We might add a menu at the start or something, I don't know. What I also want to get onto doing is trying to deploy our application on like an Android phone. I think that that's going to be the easiest because that's what I have to access to. I also have access to a Windows Phone, which I might try, but no promises there. So let's get into what we're going to be doing today. As before, I have already written the code. I'm just going to explain what it does. So in the last lesson, where we got up to was everything except pinning pieces. So by pinning a piece, what I mean is if you have a piece so let me just hopefully demonstrate this quite nicely. Let's see, this should work. So this pawn, when it's black's turn, should not be movable, as you can see, as I've made the program now. But before I've made this change, I would be able to move this pawn to like here, to this spot, to 3-3. And then that will mean that my white rook would be able to kill the king, but we never want to be allowed to do that. So, which is why we're going to have to be pinning pieces. That does also mean that we can pin any piece, but the only pieces which can pin are the rook, the bishop, and the queen. There are no other pieces which can pin a piece. And to pin a piece, there has to be the king straight behind it. So to demonstrate, if I did the following, this piece is not pinned. Neither is this piece, neither is the king. However, if I moved one of these pawns, the other pawn will be pinned. Let's undo that move. If I move this pawn would be pinned. So that's what we need to achieve today. And, well, let's get into the code. These are the 5 scripts that we are going to be editing today. So we have the rook, bishop, queen, which are the pieces which can pin. Then we have, in general, the piece, and then the game manager, which is where we basically control everything from. So let's start off in the piece. The only change we make in here is by adding a new variable, which is going to be a piece variable. Public piece, pinning the piece equals null. That's all we need to change inside of the piece. We are going to be using this variable to see which piece a piece has pinned. So a queen might pin a pawn, or a rook. In our example, a rook was pinning a pawn. Yeah, a rook was pinning a pawn. So that variable is going to allow us to store the pinned pawn somewhere, so that we can later on remove its valid moves, so that it can't move anywhere. So that's the only thing we add into here, and then we can just close that down. Next, let's move on to the rook. Again, as we've done many times in the past, the behavior from the rook and the bishop just go into the queen. And the behavior between the rook and the bishop are pretty similar for the changes that I've made. So, inside of both the rook and the bishop, we add 4 variables, well, 6 new variables. I'm just going to talk about the rook right now, sorry, so that we don't get confused. Those variables are 4 integers, as you can see here, and 2 booleans. So the way I have done it, I'm just going to explain it first visually, and then I am going to go into the code. The way I've done it is, if you have say a rook, let's just get the rook out here, somewhere in the middle, so that it's easier to talk about it. There we go. So if you have a rook, it's going to be attacking down, left, right, and up. Now, for it to be pinning a king, or a piece, there has to be a king in its path, where it's not directly attacking it, but the king is just one piece behind, is hiding behind just one piece. So let's actually move here. I think that would be more appropriate for the sake of the example. So as you can see, this rook is not attacking this king. So what I do is count how many pieces there are between my rook and between my king. If there is one piece, then that piece has to be pinned. I should not be able to move that piece when it's black's turn, and if I'm black. Next, if there was a piece here, however, nothing would be pinned. So if I counted that there were two pieces between my rook and my king, then I don't pin anything because, well, there are two pieces there, and that's how chess works, obviously. So I do it by counting, and I also do it by I have to consider the other variables which have a play in this. Variables, I mean the way I've made my program, which is the way that everything is scanned. So as you remember, the board is scanned, I think I said bottom, right to left, bottom to top. Is that what I said? I'm not too sure, but because of however it was scanned, I've explained this better in earlier videos. I have to take that into consideration. So let's play with these two variables first, I think. Nope, we play with these two variables first. So down and left. So down and left get scanned first, if I can remember correctly. So you scan, so you scan left to right and bottom to top, by the looks of this code. So if you do that, then you can find the king. And if you find the king, then found king down equals true. And so what I do is, let's look at something. Let's look at this. Imagine this is a black rook and this is still a white king. So what I do is I start scanning the board. I find that the king is here, okay? I count up by one. I count that the pieces between my king, down pieces counter after king. I include the king in this count as well, so I have to consider that later on. If it's 2, then I know that there is one piece in between them. So I include the king. I start counting. I find the king that's included in the integer of down pieces counter after king. So the king is 1. Then I continue counting. So left to right, then I go into the next row. Again, left to right. In this column, below the rook, there's another piece. So that increases my counter by 1. And now my counter is on 2, because I counted the king before. Okay? Then it goes all the way to the rook, and it stops. Now the counter is 2. After that, after I've done that to the counter, I check if the counter is 2, and if it is 2, then I pin that piece. I pin the second piece which I've scanned. And the second piece is going to be the piece which is blocking any further attack in that row or column for the rook. So that is just check down square, the piece which is on check down square. And I'm pinning the piece which is on that square. And we have used check down square in previous videos, and we can make use of it again now into something else. So maybe another example. Let's take something like this, and imagine this knight is a king. Just imagine for a moment, because it would take too much time to actually get the king there. So what we do is we scan blah blah blah. Okay, we get to here. There's one piece here which is my king, so I add 1. This is looking at the left direction. Yep, this is looking at the left direction. I add 1. I look at the next piece. I add 1 again, so that becomes 2. And it stops at the rook. Then again, I have another pinning the piece checking here, and I pin this pawn. Now, what would happen if, well, we had something like this? That can move there, why not? Actually, no, I don't want that. White's turn, that there, white's turn again, there. So, what happens now? Well, I count left to right, so 1, my counter is 1, 2, 3. Well, my counter is 3, so I should not be pinning this piece. Well, I'm not pinning the piece, let me just find where I was, because down piece's counter after king has to be equal to 2. It can't be anything other than 2. If it's anything other than 2, then it's not pinning anything. So, because it's 3, it's nothing. Neither of these pieces are going to be pinned, and the king should also be free to move as long as it's not being attacked or all of the other things are taken into consideration. So the way I do this in code, you might have already seen it as I was scrolling past. I have jaded pieces in square is king. So to start the counter, I have to check that the piece which I'm currently looking at is the king. So again, we're still imagining that this knight is a king. I start counting. So if there was, actually maybe doing this. If this was the case, then the counting starts from here. So we have 0, 0 again. And that's 0 because the piece which I'm looking at is not a king. So we're not going to enter into here. And then it gets onto the king. And, well, it finds it is a king, okay? And it's the opposite color. Now I have to check this so that I'm not pinning my pieces because of my own king's position, because that's just stupid and it's not how it works. So that also has to be true, or found king down. Now I use this boolean because, well, once I get onto this pawn, it's not a king, but I want to increase the counter by 1 once again because I've already found the king. So it's either this is the case or this. And I change this to true over here. So if I've already entered on the basis of this and increased my counter by 1, then I should be able to just do this. If I really wanted to, I could, instead of or found king down, I could check that down piece's counter is greater than or equal to 1, but I'm just going to deal with a boolean. I think it makes more sense. So yeah, that's the way I deal with it. Hopefully that makes sense. Now that's for the down and left directions only. What about the right and up directions? Well, that works similarly, but I pin the piece straight away there because I don't have to do as much checking. So that's that and that we have covered. So let's get onto this. So this is the right and this is the up direction. If I explain the right, the up should make sense straight away. So the checking here is, well, because I'm scanning after because the scanning goes left to right, bottom to top. Now imagine that this knight is my king. So what happens? I can just count how many pieces are between my rook and my king. So if I go up, there's one piece here, and the second piece is a king. So I know that I have to pin this piece straight away. If there are 3 pieces in the way, then I don't pin anything. So how I do that in code, each time I see a piece, I increase the right piece's counter before king by 1 straight away, because we're looking at where the rook is right now, and all of the pieces between the rook and the king. So there's only 1. and I can do that in this way, in this direction, because I'm scanning in this certain way. So I'm just using my knowledge of the way I'm scanning the board to my advantage. Or disadvantage above here, but whatever. Because you can't scan everything in one go. You can't, unless you did multi-threaded processing, but then you would still have to do different consider it. You would still have to consider it in different ways, but I'm not going to go into that. So if that's 2, and the piece which I'm currently looking at is the king, so counter here would be 1. It's not a king. It doesn't enter this if statement. Next, counter is 2 because I increased it before I do the check. So if that's 2, okay, that's true. And J is king, that's true because we're imagining it is. And J.piece and square is white again if it's of the opposing color. And check right square, blah blah blah. So, and the piece which I am pinning is also of the opposite color because I should not be able to pin my own pieces. That again is stupid. I pin the piece which is check right square. And check right square, well, okay, maybe we should be looking at the up direction. A check up square is just this piece because, well, we assigned it using this, which we did quite a few videos ago now. So that's the right and up direction. Now let's actually go back to the left and down just to explain what this part of the code does, which I actually forgot to do, sorry about that. So this should make sense to you now. And check down square, again, we do the same check and we make sure that the piece which we are pinning is of the opposing color and not our own piece, because you should not be able to pin your own piece. That doesn't make sense.